All right. F of x.
Yes?
Equals negative 3x squared minus 4x plus 2.
Plus 2. Very good. What type of function is this?
That is a quadratic.
Awesome. This is a quadratic function. Excellent. Good. So now the difference quotient will be given to you. It's not difficult, but you don't have to memorize it if you don't want to. It will be given to you in the question. So it will be f of x plus h minus f of x divided by h. There are three pieces that need to be put together here, right? The first piece is this. The second piece is the function which I have, and h, which is that little bit that no one can do anything to. So the only piece that I did not determine and I did not simplify is that piece of f of x plus h. Would you agree? Perfect. So that's where my starting point is. So can anyone dictate what to write? Again, this is based on looking at the function and understanding the pattern. If I look at the function and I understand the pattern, I can evaluate it for whatever you want me to. So, can anyone dictate what to write here?
Yeah.
Now this is not part of the difference quotient. I should be able by now to evaluate this function for anything. What will you do if I ask you to find f of 3? What will you do?
Okay, so I think I know what to do. Is it
You will replace x by
yeah. So it's 3
no, negative.
negative 3.
Perfect.
Parentheses.
Yes.
X plus h.
Very good.
Close parentheses squared.
Awesome. Minus 4.
Minus 4 parentheses x plus h plus 2.
Perfect. Awesome. That's all I needed. So once I see the pattern says negative 3 times blah squared plus minus 4 times blah plus 2. If blah now is x plus h, all I have to do is just replace the blah everywhere with x plus h. Does it make sense? Okay, so now I cannot distribute. Don't even try to distribute negative 3. Why I cannot distribute? Exactly. Awesome. So then I have to write negative 3, and then what do I write? And for this part, we have an agreement from day one.
X squared.
Thank you.
Plus x plus h. Right? I mean xh. 2xh.
Thank you. Plus?
H squared.
Awesome. Minus 4x minus 4h plus 2. Only now I can distribute a negative 3, and I will. So negative 3x squared minus 6xh minus 3h squared minus 4x minus 4h and plus 2. And now I can say I do have this piece. I simplified it, I expanded it, I did whatever I needed to do with it. I have it now. Is that okay? It will be replaced by all this. So now my next step would be to put all these three pieces together. What has to happen before I even write? This should be on my mind. What has to happen? There are two things that have to happen here.
You have to cancel.
What will cancel?
All the terms without h.
Exactly. If not all terms without h cancel out at the top, something is wrong. And what is the second thing that must happen? Yes, the
Equally h from the eventually h from the denominator will simplify
exactly.
with h from the numerator.
Because all the terms without h will go away, and the remaining terms will have an h in common. That will help us simplify with the h from the bottom. Exactly. So at this point, I'm going to just copy all this. Negative 3x squared minus 6xh minus 3h squared minus 4x minus 4h plus 2. This is just this piece. Now I reach the minus, but minus needs to be distributed to all three terms. What would you tell me to write?
Plus 3x squared.
Very good. Very good. Awesome. And now the denominator. Once you remember these, the two things that have to happen, you are on the right track. Okay, so can anyone tell us what goes away?
3x squared.
Yes, with a negative 3x squared. Like, we cannot fabricate it. It has to be there, right?
Mm-hmm.
Good. Next.
4x.
Yes, with a negative 4x, correct. And
2.
with a negative 2. Perfect. How many terms are remaining at the top? Good. What do they have in common? Good. Because eventually this will go away. So now please tell me what we have in parentheses. And that's the end of it.
Negative 6x.
Negative 6x, I agree.
Mm, 3 minus 3h
I completely agree.
minus 4.
That's it. And this is the final answer, negative 6x minus 3h minus 4. This is it. It gives a rate of change of this function at any point. Understand the conditions, of course. Very good. Awesome. Is this clear? Okay. Other questions? Is there anything else? If you have anything else for me. Yes,
Why did
please.
we flip the signs again? When we write it down.
Negative 1 times negative
Okay,
3x
okay.
squared. Negative 1 times negative 4x. Negative 1 times 2.
Right.
Now, you have a point. Because I should have written it in parentheses so that you don't forget. I just thought that it would, because we have so much to write, I just thought that maybe we remember this, that we have to switch the symbols because of this, but it would have been much better if I had written the minus and parentheses around f of x. That would have been easier to understand. But is that okay with everyone? Do you want me to write it one more time? Is that okay? Yes?
Yeah,
That's
that
good.
one's good.
Okay. Let me know. Yes, please.
I got another one.
1 second. Yes.
Find the difference quotient f of x equals 8 over x.
8 over x. Very good. Is that what you had in mind?
No, but I'm down.
Okay, let's do that. So this time we have a function, which is 8 over x. What type of function is this?
Rational.
Awesome. Very good. It is a rational function. We will discuss this in chapter 3. Rational function. Perfect. We are asked to determine and simplify the difference quotient. So here's the difference quotient in general is f of x plus h minus f of x divided by h. What do we have and what do we don't have? We do have the f of x. It's given to us. We sort of have the little h. We can't do anything to. But what about f of x plus h? The answer is no, I don't have it. But this does not need a lot of work outside of the difference quotient. So can anyone give us f of x plus h for this function? Of course, 8 over x plus h. Exactly. That's all it is. Minus 8 over x divided by h. That's it. There's nothing else to it. I just have to, the function says 8 over blah. And blah is x plus h, of course. What do I do next? Yes, but what do I do? Can anyone suggest what to do to the top, please?
Multiply by 8.
If it's a proportion, I will cross multiply, but you are on the right track because I know what you want to say. Of course. I cannot add, but I know what you mean. I know what you mean. You meant the same thing. Okay, we have to find the LCD. We cannot add or subtract fractions that have different denominators. Perfect. So what is the least common denominator, please?
X plus 8 x.
Exactly. The product of the two factors existing in the denominator. Awesome. Very good. Well done. So now please tell me what we have at the top. For the first one, we have x. Great. For the second one, of course, what it does not have. Can anyone dictate the numerator?
8x
Very good. 8x is true.
minus 8x
Very good.
minus 8.
Very good. Awesome. Very good. Again, what has to happen when we calculate and simplify the difference quotient for any function? Again, two things must happen. What is the first one? With x without h. Yes. In other words, some terms may go away even if they have h, but that's a bonus. It happens by chance. But what must happen is that all terms without h must go away. Is that true here?
Yes.
These two go away. Now I have two fractions. Look at this, the top fraction and the bottom fraction. How do I divide two fractions? I copy the top fraction and I indeed multiply it by exactly.
Is that -8?
Yes, it's a negative right here.
Oh, I see where you.
Negative of a positive, I'll put it in front. So what was the second thing that we just discussed that must happen here? Simplify, the h in the denominator must go away. So all terms without h went away at the top, and then eventually h in the denominator must go away. There's still an h left in the problem, but not the one that we had in the denominator. That one disappeared. So this is -8 divided by x times x plus h. And this is the difference quotient for the given function. Well done.
Yeah, those ones were tripping me up. Good question.
Very good question. Anything else?
This one might be a little dumber, but I got 7x.
Yes?
Over 4. No. Square. It's in the power of 4. What's that called? Yeah, there you go. Yeah. Minus 56x. And then solve for x. So find the solution. So we gotta find. I know we have to find 4 solutions. That's it.
But-
equals 0. Equals 0.
Okay, so a 7 is inside the 4 power, or this is 7x to the 4th minus 56x. So not this. Okay, good. First question that I ask myself is,
What kind of
awesome, what type of equation it is? Very good. What type of equation is it? So what type? Polynomial. Very good. I just didn't hear. Sorry about that. It is polynomial. Perfect. Then,
Did I me a test? A question on the test? What kind of?
no.
Okay, good.
No, but if you don't identify it correctly, how will you be able to solve it correctly?
Luck.
Okay,
Not gonna lie to you.
okay. Very good. First video from the class before uploaded, and the other one, it said it takes 2 hours. So I had to stop it. Okay, very good. So it is indeed a polynomial equation. And I will always simplify it first. And I can simplify dividing both sides by? Never divide by the variable. We wrote that. This is at least the second time. Because if I say 4 solutions and I divide by x, how many solutions will I get?
3.
Yes, instead of? Exactly. So I can only divide both sides by 7. So this is x to the 4th minus, is it 8x equals 0? Good. I still have 4 solutions. I will do what? I will have to factor out the greatest common factor, which is, very good. And what do I have in parentheses? X cubed minus 8. And now I have to look at x cubed minus 8 and I have to make a decision. It's a binomial. It's in descending order. I'm hoping for a special product. Is there a special product applicable here?
Difference of cubes.
Wow. Excellent. Did you hear what difference of cubes? Difference of cubes. Well done. Once we say the difference of cubes, what will you prepare? A what and a what? Binomial and a? Very good. I need the binomial, please. Awesome. Well done. This is what I call effort.
X minus 8.
I can't. Perfect. Then, the difference, sum. First term.
X squared.
Very good. Middle term.
8x.
Middle term. 2, no, not 2ab, that's a different formula. Just the product of the two. Not the 2 times ab, but just ab. And then plus,
4.
that's it. The first solution comes from here. X equals.
1.
So if 1 is 0, then it's 1. Is 1 0?
Oh, X is 0.
Perfect. The second one comes from here. X equals. Very good. And the other two will come from here, but with some effort. Because this is not factorable. And what is my other possibility? The only chance I have is correct. X squared plus 2x plus 4 equals 0. Should I continue, or is it clear from this moment on?
It's clear.
Okay, so negative b plus or minus, and here are my 4 solutions. If I had divided by x, this solution would have been gone. Would have not appeared anymore. So x equals 0, x equals 2, and 2 solutions from here, 4 solutions total. Very good. I'm sorry?
Can you use factoring method?
This is never factorable. You cannot find two numbers whose product is 4 and whose sum is 2. They don't exist. That's why we have to use the quadratic formula on this. Good question. Anything else? Is there anything else? Okay, let's go back to transformations and finish that up in a few minutes and start reviewing. So for those of you who just came in, Joe, for those of you who just came in, Saturday from 9 till 10, I will be in this room for a review. If you're interested, please come. I have another group who's coming, and there will be plenty of room, I'm sure. Is anyone interested? Roughly, I would like to know how many. Okay, fine. If 1, 2, 3 are coming, I'm fine. I will be here.
9 a.m.
9 a.m. till 10 a.m. Yes. Okay, so I reserved this room. I haven't gotten the confirmation yet, but I'm hoping that it's going to be okay. If not, I will put a note on the door, and I'll say I'm waiting for you in such and such room. Okay? Very good. So let's go back to transformations. And we looked at transformations. Let me just refresh my memory for a second. By looking back, we only looked at, if I remember correctly, I just closed that by mistake. We only looked at horizontal and vertical, nothing else. Okay, so let me refresh your memory on those, and then I will show you vertical stretching and shrinking and reflection, and then we'll start reviewing. Okay, so for example, if we have f of x equals x plus 3 everything squared minus 4. So let's suppose we are given this function and we are asked to identify transformations and graph the function. Not only identify transformations, but graph the function. Okay, in order of operations, transformations have to be presented in order of operations. The first question I asked myself is this: what function was used to create this one? So I just came up with a function. Which base function did I use to create this specific one?
Quadratic.
Yes. Which one's clearly quadratic? Very good. So the base function is awesome. Now, in order of operations, what will be the first transformation applied to x squared?
Oh,
I am changing x into x plus 3. That's the first transformation. So this is x plus 3 squared. What does this do to this? Very good. Left 3. So left 3 units. Number 2 is a transformation on number 1, which will be x plus 3 everything squared and minus 4. What transformation is this? This is not a transformation on the base function. It's a transformation on this function from number 1. What does this do to that? Very good, down 4. So now we're going to graph all these. Let's graph x squared. This is the base function, x squared. Next, you told me to shift this 3 units to the left. This is exactly what I'm going to do. I shifted it 3 units to the left. And then you told me to move this graph, the green graph, where? One more time. Down 4. So here it is. So this is x plus 3 everything squared minus 4. So we graphed a rough graph. This is not a super accurate graph. The only thing that I can determine is the vertex. We will talk about the vertex again in chapter 3 right away. That is for sure clear, right? So there is no discussion there. So my question now is, can anyone identify the vertex for us? Very good. -3, -3, 3 to the left, and down 4. -3, comma, -4. That's the vertex. And this is what we did last time. Now let's take a look at the next one, number 2 and 3 together, and number 3 and 4 together. 3 and 4 together. Okay, ready? So let's suppose we are looking at the function the square root of -x and the function negative the square root of x. Now the question I have is, again, which basic or base function was used to create f and g? Very good. So the base function is the square root of x. Perfect. Now the next step is I have to identify what is changing. When I look at the square root of -x and the square root of x, I have to figure out what changes. Does x change from x to -x, or does y change? The answer is x changes, right? I had the base function, which is the square root of x, and now the square root of x, it's not the square root of x, but it's the square root of -x. So this is a change in, so the square root of -x is a change in x. Now let's see of what type. So if I say 5 and then -5, what am I trying to do here? 5 and then -5. I am reflecting the graph over what? From 5 to -5. Very good. So this is nothing else but a reflection with respect to WRT, the y-axis. Let's graph this function. First, we will be graphing the original function, the base function, which is the square root of x, which we know we studied last time how it looks. And now I'm going to reflect the graph with respect to the y-axis. So this is the square root of -x, a reflection with respect to the y-axis. Now let's go back and analyze g. Let's analyze these two functions. This is the base function, but now it's negative the square root of x. Does x change, or the y value changes into -y? Y value changes. So I'm going to make myself a note. Negative the square root of x is a change in y. What type? So here's y. and I'm multiplying it by -1. Where am I going?
Down.
So this is a reflection with respect to, yes, WRT with respect to the x-axis. Let's graph that function together. Look here carefully. Here's the graph of negative the square root of x. So when I change x into negative x, it's a reflection with respect to the y-axis. When I change y into negative y, it's a reflection with respect to the x-axis.
Where's
Last,
neg-
yes?
where's the negative? Where's the negative x coming from? The negative.
I created two new functions. I created two
Oh,
new functions.
that's one.
Yes. I created f of x, which is the square root of negative x, and I created g, which is negative the square root of x. To illustrate the reflection with respect to the y-axis and the reflection with respect to the x-axis. Last one is number 5 or 6. What? Yes, please.
My only confusion here is
Yes.
when you say the reflection will reflect respect to x or y.
Yes, if I change x, it's with respect to y.
Yeah, but the word this is the horizontal, right? This is the x-axis.
Correct?
And that's the vertical, that's the y-axis.
Yes.
So if the reflection of, for instance, the green, it's going towards the right.
Yes, because
Which is on the x-axis.
so
right?
all the positive x values become negative.
But how is it with respect to y? That's my question.
Okay, so if I ask you to plot -3, x equals -3, you will plot it this way, right? If I ask you to plot +3, you will plot it this way. So it's a reflection with respect to the y-axis. All positive values are reflected with respect to the y-axis and they become negative. All negative values are reflected with respect to the y-axis to become positive. But if you want to talk about y, all positive y values are reflected with respect to the x-axis to become negative.
So our origin is with respect to
So it's making the y values negative. Like your x values are still going to be positive. So you're still going to be going towards the right, but your y values are now negative. So that's going to put you on the bottom portion. You see what I'm saying?
again, but the explanation as well. Again, the concept. The explanation and my understanding.
Is that better?
Then why is the negative x down instead of the reflex up?
It's negative y. It's not negative x. So x gets changed into negative x for a reflection with respect to the y-axis. The y value is changed into negative y value for a reflection with respect to the x-axis.
So the g of x is a y value. G of x.
So if the negative sign touches x, it's a reflection with respect to the y-axis. If it's outside and it touches y, the y value, then it's a reflection with respect to the x-axis. See this? See the difference?
Mm-hmm.
Negative touches x. Here, negative does not touch x. It's a completely outside. So it refers to y, not to x.
Okay.
Better? Okay. So can you remind me whether that was number 5 or 6? I think it was number 5 in the list, right? For vertical and vertical stretching and shrinking, correct?
Oh,
The
yeah.
horizontal one was number 6. Am I correct?
Yeah, stretching is, so vertical is 5, and that's under stretching and shrinking.
Very good. That was the last one we have to cover, and then we'll leave the last one, the number 6. So this is number 5. Okay, so let's look at the following. So f of x equals twice the absolute value of x, and g of x equals 1/3 the absolute value of x. Which base function was used to create this function? These two functions, actually.
Absolute value.
Of course. So the base function is the absolute value. Good. Now let's look at the graph of the absolute value. If you remember, what type of function is that? We use a familiar name to remind us of the graph of the absolute value. What is it? Like a what? Like a v. Very good. Awesome. It's like a v function, the absolute value. So this is the absolute value of x. So now let's analyze the following. If this is the graph of the absolute value of x, what do you think about twice the absolute value of x? In other words, let's say for x equals 1 here, I hope you agree it will be this value, 1, 1, correct? But what if I have a 2 in front? Where will this point go? Will it go up or will it go down? Up. In other words, it will go to 2, correct? So when x is 1, the y value is 2 for this. When x is 1, the y value is 1 for this, correct? So from the graph, when I multiply the y values by a number greater than 1, the graph will be stretched vertically by a factor of 2. So here it is. So here's the graph of twice the absolute value of x. Now let's graph the other one. So here I have the absolute value of x, but now I want to multiply all y values by 1/3. Will it do this, vertical stretching, or vertical shrinking of the graph? Right, because this time I will have to divide this by 3. So the new graph will be this. So this will be 1/3 times the absolute value of x. And this is the end of the transformations for now. Now I would like us to look at a combination of all these. So let's say we have a function which is f of x. It's -2 the square root of x plus 1 and plus 4. I claim that this function was determined using a base function that you will give me in a moment, using 1 transformation, 2, 3, 4 different transformations. I have to present them in not descending order. I have to present them in the order of operations, as if I were to evaluate this function. You cannot say plus 4. You have to start from the inside. You have to add 1. And then you have to take the square root. Then you will multiply by 2, and then by -1. And then only in the end is 4, plus 4, correct? By the order of operations. So first, let's establish which function we used, which base function we used to create f of x. Of course, very clear, is the square root of x. That's the base function. Perfect. Now, the first transformation that is on the base function, in order of operations, what will you tell me to write? Correct. Awesome. It's the square root of x plus 1. When I change x into x plus 1, what do I do to the graph of the square root of x? Move it left 1. Very good. Awesome. Left 1. Perfect. What is the next step? And I know you would say, now multiply by -2. I cannot multiply by -2 because there are 2 transformations in -2. First, I will multiply by 2. So 2 the square root of x plus 1. What does this do to the square? No longer this. This is gone. Now this is a transformation on number 1. Careful. If the number outside is bigger than 1, remember the absolute value of x, and twice the absolute value of x. The absolute value.
It like shrinks.
Okay. Yes, we call it. That's fine then. So it's a vertical stretch by a factor of 2. Now number 3. Now I have to put in that negative because it's a different transformation. Am I changing x or am I changing y? If you say you're changing x, then I would have to reflect with respect to the y-axis. But if you say you're changing y, then I have to reflect with respect to the x-axis. Exactly, because it's outside. It doesn't touch x. So it's a reflection, reflect with respect to the x-axis. Perfect. And now the last transformation is a transformation on function from 3. So -2, the square root of x plus 1 plus 4. Where and what do I do to function from 3 when I add 4? Does it change x or does it change y? It changes y. So I will do what? Up 4. Good. So let's show all these transformations. First, I will graph the base function, which is the square root of x. Here it is. Then you told me that I have to shift this graph 1 unit to the left, correct? Very good. I'm going to do just that. So this is the square root of x plus 1. Then you told me to stretch the graph by a factor of 2. Okay, this point doesn't go anywhere because it's at x equals 0. I'm sorry, y equals 0. But this will double, right? So this is the new graph, which is twice the square root of x plus 1. Then you told me to do what to twice the square root of x plus 1? Not yet. We are in number 3. Yes, I have to reflect. So this is -2, the square root of x plus 1. And finally, you told me to do what to this graph?
Move it up 4.
Up 4. So 2, 3, 4, something like that. So this is -2, the square root of x plus 1 plus 4. In case you're asking me why is this important, it's because some of you may be able to get into data analysis, and you may be able to fit functions. So that's why this is very important. It's a very important concept.
Oh, yeah.
Say it again. I'm going to post this. Okay, very good. Any questions? Should we look at another example before we start reviewing for the test?
I have a question, but it's not
Yes?
in regards to the actual.
Okay, sure.
So last night, I believe 2.4 or 2.5, whatever we're doing right now, was due, but we didn't finish this actual, so I was running. What is that?
So all the material for test is due the day before you take the test. So if you leave something for some time after the test, then I'm going to just deduct some points. So if you finish everything between now on everything from chapter 1, including from chapter 2, 2.1 through 2.5, before the test on Monday, then you'll get 100% for the homework. If you don't, then you will get, and you finish it the next week, then you'll get 90% maximum. If you finish it in 2 more weeks, then you'll get 80% maximum. So I want everyone to finish everything between now and the test,
Okay.
because otherwise you're not going to be prepared for the test. Also, the interim grades are due on Thursday. Any questions, please? Any questions? Any questions? So please don't talk. Please don't talk. Please don't talk.
Which ones are the interim grades?
Interim grades are due on the 3rd, and it's an assessment in which I say the student is following the instructions and the student is doing well or the student is not doing well. That's why the test has to be on Monday. So I can grade it by Wednesday and turn in the grades on Thursday.
Oh, so that one you are the one doing it is not on my lap.
The interim grades are an assessment only.
But you are the one doing it, right? Are you the one doing that one, or it's also on one section on my lap?
The interim grades are an assessment that I turn into the school.